Road to Olympiad.
Welcome to RTO. Consider the following problem. In triangle ABC, given that cosine A over sine B plus cosine B over sine A is equal to 2, and the perimeter of triangle ABC is 12, find the largest possible area of triangle ABC. This one is going to be a pretty tough problem, and the solution is going to be long for today. Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start from the equation cosine A over sine B plus cosine B over sine A is equal to 2. Multiplying both sides by sine A sine B, we have sine A cosine A plus cosine B sine B is equal to 2 sine A sine B. Move the 2 sine A sine B to the left hand side, we have sine A cosine A minus sine A sine B plus cosine B sine B minus sine A sine B is equal to 0. Factor out the sine A and sine B, we have this one. Here we can rewrite cosine A as sine 90 degree minus A and cosine B as sine 90 degree minus B. This is because we want to use the product sum identity to rewrite the difference between the sign as follows. Here we notice that both the term can be factorized by 2 sine 90 degree minus A minus B, the whole thing over 2. And we get this one. To make the thing slightly easier, we let x is equal to A minus B over 2, and we can rewrite the equations as this. Now we try to use the addition formula for the cosine to expand the cosine in the equations. And note that both cosine 45 degree and sine 45 degree are both equal to square root of 2 over 2. We get this, which we can factorize the square root of 2 over 2 into this one. Here, let's clean up the thing a little bit first. Here, we are going to claim that the expression in the big bracket is not equal to 0. Notice that we can expand the brackets to get this, which we can do something similar like just now by rearranging the terms and factorize out the cosine x and sine x into this one. Again, we are going to apply the product sum identity to get this thing. Putting the A minus B over 2 as x again and expanding the brackets, we got this one. Now, notice that A and B are both angled in triangle ABC, and thus this must be less than 180 degree. This is to say that A plus B over 2 must be an acute angle. And from the expression above, a perfect square multiplied by the sine or the cosine of an acute angle must give us a positive number, and thus their sum must give us a positive number as well. Therefore, our claim is valid, and thus, in order to make this equation equal to 0, we can only have square root of 2 sine 90 degree minus A minus B over 2 is equal to 0. This is to say that the sine must be equal to 0. To make sine is equal to 0, we need to have the angle inside it to be equal to 0. In fact, sine 180 degree and 360 degree will give us the answer 0 as well. However, in that case, we will get one of our A and B a negative numbers, which is not what we want. Coming back to these equations, solving this equation will give us A plus B is equal to 90 degree. This is to say that triangle ABC is a right angle triangle at C. And the side A and B will be the base and the height of the triangles, and thus the area of the triangle can be calculated by using the formula half A times B. Now let's come to the perimeters. The perimeter of triangle ABC is given to be 12, so we have A plus B plus C is equal to 12. By the Pythagoras theorem, we have C is equal to square root of A square plus B square. Here we are going to make use of the AMGM inequality and some extension from it, where we can square the both sides, expanding the square and subtracting 2AB from both sides. By using these two inequality, we have A plus B plus square root of A square plus B square must be greater than or equal to 2 times square root of AB plus square root of 2AB. Factorizing the square root of AB, we get 2 plus square root of 2 times square root of AB. And since the left hand side of the inequality is equal to 12, we have square root of AB is less than or equal to 12 over 2 plus square root of 2. Rationalizing the denominator by multiplying 2 minus square root of 2 and simplifying it, we get 6 times 2 minus square root of 2. Squaring both sides, we have AB is less than or equal to 36 multiplied by 2 minus square root of 2, the whole thing square. And thus, half AB will be less than or equal to 18 times 2 minus square root of 2, the whole thing square. This is to say that the area of the triangle ABC is less than or equal to 18 times 2 minus square root of 2, the whole thing square. And thus, the maximum or the largest possible area for triangle ABC will be 18 times 2 minus square root of 2, the whole thing square. And this marks the end of our solutions. Post in the comment below if you have any thought on the video. And if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.